Good day, my wonderful viewers out there. You are welcome to Physical Education. Today in mathematics, we shall be looking at introduction to indices. Now, in this indices, we shall be looking at the various laws of indices. And among these various laws of indices, we have the first one that says that a raised to the power of n times a raised to the power of n is equals to an plus n. And that the second one, that a raised to the power of n divided by a raised to the power of n is equals to a raised to the power of n minus n. Then we have the other one, which we also call the power law, that a raised to the power of n bracket n is equals to am times what? N. That is a raised to the power of n times n. Then we have the other one of a b bracket n equals to an times bn. That is the separation of powers. That is when you have a and b. A and b are two different prime numbers, but all are being controlled by the same power, and that power is n and n. That is why we have the separations. So we have it that a raised to the power of n times a raised to the power of times b raised to the power of n. The same thing as bracket ab bracket raised to the power of n. Then when we have bracket a over b raised to the power of n equals to an over bn. So the n affects the numerator and also affects the what? The denominator. Now these are the notable theorems. These notable theorems must be conscious of them. That when we have a raised to the power of 0 is equals to 1, that is to say any number that is raised to the power of 0 is equals to 1. Now we have the a inverse. A raised to the power of minus n is the same thing as 1 over a raised to the power of n. That is called the reciprocal law. Then we have a raised to the power of n over n is equals to n root a, or in bracket n. So we are going to see how we can use some of these principles in solving some basic problems on indices. And remember, every indices problem must exist as a prime number. And for you to apply these basic laws of indices, you must make sure that the existing prime numbers are common to each other. That is why we have here as a, and then a. And what are we trying to say? That it is the existence of these prime numbers, their raised to their powers, that produce what? A whole. For instance, now when we have 4 as a whole number, and we have it that 4 should have an index, and what should be the index of 4? The index of 4 is 2 raised to the power of 2. And what do we mean by 2 raised to the power of 2? 2 raised to the power of 2 means 2 into 2 places. That is 2 times 2 is equals to 4. Now instead of that putting 2 times 2 equals to 4, we put it as 2 raised to the power of 2, which is equals to 4. So we are going to see how we can use these principles to solve some problems. Now let us take example 1. Example 1. Assuming we are told to evaluate two bracket x plus 1 equals to 1. This is a question on indices. This is a question on indices. We are asked to solve this question. Now, in solving this question, what do? We must remember that in solving these questions, that we have basic principles that guide them. Now, we'll say solution. If we have i.e. 2 bracket x plus 1 bracket equals to 1. Now, let us remember in this our basic theorem that a raised to the power of 0 is equals to 1. And if you watch here, this 2 that is being used here is what? Is a prime number. That is to say, i.e. that 2 raised to the power of 0 is equals to 1. Which is the notable word? Theorem. That a raised to the power of 0 is equals to 1. Now you put it here that a raised to the power of 0 is equals to 1. You are obeying this principle. That is to say that anywhere we see 1, we put 2 raised to the power of 0. So we'll say i.e. 2 bracket x plus 1 bracket close will be equals to 2 raised to the power of 0. Now if you watch now, these two prime numbers are what? Are the same. we see this cancel this to give us bracket x plus 1 bracket close equals to 0. So when we remove the bracket, it becomes i.e. x plus 1 is equals to 0. Now let this one come here. If this one comes here, we'll have it that our x will be equals to minus 1. So x is equals to minus 1. So x is equals to what? Minus 1 in this question. So now, with this knowledge of solving this simple problem, I'm going to give the activity for you also to try and solve in relation to the way I have done it here. Now remember, we are looking at introduction to indices. This is the part 1 of this indices. When next we come in this topic again, we shall solve multiple problems that we can use the principles of indices in solving. But before that, this is your own activity for you to do. Activity, you are to evaluate the following. You have A, you have 9 raised to the power of 2x equals to 27. Have B, 25 times 5 raised to the power of x minus 2 equals to 1. Then we have C, 64 bracket 2x minus 3 bracket close is equals to 8. So you have to find the value of x in this very activity. Thank you for tuning to this channel.